There are billions of habitable planets in our galaxy alone.
The James Webb Space Telescope is shaping up to be one of the most significant breakthroughs for humankind regarding space observation. Being far more powerful than all other space telescopes ever launched by humans, the scientific community has high hopes. It will enable them to study very distant objects in space as they have never been able to. One of the objects the JWST will study is Proxima b, to see whether artificial lights are coming from the planet. Yes, you heard right. Scientists want to know if the lights coming from Proxima b are due to aliens. What will the JWST see when it focuses on the exoplanet, and how does it affect you? Join us as we dive into the James Webb Artificial Lights discovery on Proxima b that changes everything. Exoplanets dot the universe and contain lots of secrets. These are any planets located beyond our solar system. Most of them orbit other stars, but free-floating exoplanets called rogue planets orbit the galactic center and remain untethered to any star. While exoplanets are plentiful, most of the ones discovered so far are in a relatively small region of our galaxy, the Milky Way. In actual fact, there are more planets than stars in the galaxy. By measuring exoplanet sizes using diameters and masses using weights, scientists can see compositions ranging from very rocky, similar to the Earth and Venus, to very gas-rich, like Jupiter and Saturn. Exoplanets are made up of elements identical to those of the planets in our solar system, but their mixes of those elements may differ. So you can have some planets dominated by water or ice, while others are dominated by iron or carbon. Astronomers have identified lava worlds covered in molten seas, puffy planets the density of styrofoam, and dense cores of planets still orbiting their stars. The first exoplanets were discovered in the 1990s, and since then, thousands have been identified using various detection methods. However, it is pretty rare for astronomers to see an exoplanet through their telescopes the way you might see Saturn through a telescope from Earth. That's called direct imaging, and only a handful of exoplanets have been found this way, and these tend to be young gas giant planets orbiting very far from their stars. Since these exoplanets are hard to spot using existing telescopes, scientists have to use indirect methods to detect them. One indirect way is by measuring the dimming of a star that happens to have a planet pass in front of it. This is known as the transit method. Another method used to find exoplanets is monitoring the spectrum of a star for the telltale signs of a planet pulling on its star and causing its light to subtly Doppler shift. Space telescopes have found thousands of planets by observing transits, the slight dimming of light from a star when its tiny planet passes between it and our telescopes. Other detection methods include gravitational lensing, the so-called wobble method. Detecting exoplanets is tough, but studying them after detection is even harder. For this reason, astronomers have not been able to explore one of the most popular exoplanets, the Proxima b, as much as they wish, despite all of the great stuff they suspect it is concealing. For example, does the exoplanet host alien life? But now they have a new tool at their disposal, the James Webb Space Telescope. The JWST isn't the first telescope to be put in space by humans. NASA has a long history of using powerful observatories launched to space to study the universe. One of the most iconic and powerful is the Hubble, which has faithfully delivered stunning images of different parts of the universe over several decades. However, the JWST is more powerful than the Hubble by many magnitudes and also more expensive. At almost $10 billion, the JWST is the costliest telescope ever launched. It is also the most complicated, with several parts being designed to fold up. It was necessary to fold them up so the telescope would fit in the rocket launching it to space. Compared to the Hubble, the JWST is located very far away. The former orbits the Earth at about 350 miles, while the latter rotates about the Sun at a distance of about 1 million miles from the Earth. This means NASA can't send in astronauts to repair or reconfigure the JWST after launch. Thanks to its more giant primary mirror that measures at 6.5 meters across, the JWST can capture objects that are billions of light years away, in effect, taking us back in time. In fact, the JWST will allow us to take baby photos of the universe, because we can now get nearer to the Big Bang as much as possible. The new telescopes use infrared to pick up signals from heat-emitting objects many miles away. To protect the Space Observatory from interference from the heat from the Sun and Earth, NASA placed a shield under the telescope. The shield contains 5 layers and is so large it would cover up a whole tennis court. NASA has unveiled a mosaic of the first images captured by the JWST, representing the early stages of the telescope's 18 main mirror segments properly aligning before it reaches its full potential. While the image is admittedly blurry, it is a good starting point in the long process of adjusting JWST's mirrors to take ultra-sharp photos of the distant universe. The 18 points of light that you see in the image all represent the same star, known as HD 84406, seen by a different primary mirror segment. Collecting the light used to generate the image mosaic took about 25 hours. The 18 images of HD 84406 were pieced together from more than 1,500 images collected as Webb was pointed to various positions around the expected location of the star. The mirror will begin to align correctly following the various adjustments that the telescope will make over the coming months, and the 18 stars will eventually become one as all of the mirror segments are aligned to create a seamless surface. Now, why are astronomers interested in the Proxima b exoplanet? To understand this, you need to know its location. Our nearest neighboring star is the Proxima Centauri, located about 4 light-years away. Just like our Sun, Proxima Centauri has its own set of planets orbiting it. One of the planets is the Proxima b. This exoplanet was discovered in 2016 and has intrigued scientists ever since then. Scientists have also discovered Proxima c and Proxima d, although Proxima d is still awaiting confirmation. However, much of the attention has been on Proxima b for good reasons. Because the planet orbits right in the middle of its star's habitable zone, it's possible that liquid water and potentially even life could exist there. Because of its Earth-like mass, scientists believe that not only could liquid water exist on Proxima b, it could also be a rocky, terrestrial planet similar to Earth. Proxima b orbits around a star that, while close to our solar system, is also much dimmer and much less massive than our Sun. The exoplanet is tidally locked and in synchronous rotation with its star, meaning that one side is always facing the star and one is always facing away, a light side and a dark side. In addition, it's unclear if Proxima b has an atmosphere. However, if Proxima b has an atmosphere, the simple ingredients, water, carbon dioxide, and rock that are needed for the formation of biochemical cycles that we call life could all be present and interacting on the planet's surface. The planet lies very close to its star, completing one orbit every 11 Earth days. The temperature on the surface of the planet could be between minus 90 degrees and 30 degrees Celsius, or minus 130 and 86 Fahrenheit. What if aliens live on Proxima b? If that is the case, there is speculation that its improbable life could develop on the day side due to a constant stream of intense radiation from its host star. The reason is that Proxima b orbits just 4.5 million miles out, or about a tenth of the distance Mercury is from the Sun at its closest point. Radio signals have already been detected from the area around Proxima b. However, radio astronomers believe this was likely just interference from natural sources. So because the side of the exoplanet that is free from radiation is always dark, any civilization inhabiting the exoplanet may have to deploy powerful mirrors or require very bright LED-style lights to illuminate their cities. This can help us detect them using the right tool. This is why a team that includes Harvard astronomer Avi Loeb has suggested that the JWST can be configured to spot evidence of LED light on the planet Proxima b. They suggest that using the near-infrared instrument on the James Webb Telescope and looking for the telltale signs of LED light waves in the light from the planet and its host star, they will be able to detect this artificial light if it exists. The team has investigated whether artificial lights could be detected on the dark side of Proxima b by computing light curves from the planet and its host star. These scientists considered 2 different scenarios: artificial illumination with the same spectrum as commonly used LEDs on Earth, and a narrower spectrum that leads to the same proportion of light as the total artificial illumination on Earth. They discovered the JWST would be able to detect LED-type artificial lights, making up 5% of stellar power. If James Webb is able to detect the narrowband light that is reminiscent of LED bulbs, it will be because it will be able to characterize the atmosphere of the planet. This will allow researchers to use instruments on the observatory to detect how much energy transport occurs on the planet and then perform calculations of light curves to determine whether they match those of an LED light source or not. To come to the conclusion that it may be able to detect artificial light, Loeb and colleagues use the JWST exposure time calculator. This tool allows astronomers to predict what can be detected in any given time period based on predefined settings before the observatory launches. It allowed them to determine the possibility of detecting different flux values and detecting those with a wavelength that matches artificial light levels that should be expected from a civilization forced to live in permanent darkness. In that case, the lights shining onto the permanent night side should be extremely powerful and thus more likely to be detected with JWST. The JWST will be able to show the existence of artificial illumination for standard LEDs 500 times more powerful than those currently found on Earth's, and for artificial illumination of similar magnitude to Earth's. Let's hear what you think of the JWST discovering aliens on the Proxima b exoplanet in the comments section below.